Okay, in these problems, we're supposed to be assuming exponential growth and decay, which means we're using formulas of the form y equals a times e to the k times t, and we're thinking here of y as a function of t, where t is supposed to represent time. And a and k are constant values that depend on the problem at hand. So usually for these problems, it's your job to figure out what a and k are. But before we move on to the actual problems, there's a general, very important note to make. One is that if you plug in 0, y of 0 equals, you're just plugging in 0 for t, a e to the k times 0, well, anything times 0 is 0, so that's e to the 0. But e to the 0, because anything to the 0s is 1, so that's a times 1, it's just a. So a is always the initial amount, and y could represent the population of a bacteria, or the population of anything else, or the amount of radioactive material, or anything else. Whether it's growing or decaying, a is the initial amount. So that's a general rule that you can just remember right off the top of your head. A always represents the initial amount. Okay, so now let's actually address the problems at hand. So what we have is something which is cut to a quarter, so it's decaying and it becomes a quarter of its original size, or its original amount, in 10 days. Okay, so what's this really saying? This is saying that after 10 days have gone by, so that's e to the k times 10 times a, and we still don't know what a and k are. This is the amount at time 10 days. That's what this means. This is the amount at time t. And they're telling us that it was a quarter of its original amount. But like we just said, the original amount, the initial amount, is always whatever that coefficient a is. So that's a divided by 4. It's a quarter of a. So now what you'll notice is here's some very amazing thing. They never tell us what the initial amount actually is, but it doesn't matter because the a's cancel. You just divide by a. A fourth is equal to e to the k times 10. You take the natural logarithm of both sides, ln of this, ln of that. The ln cancels with the exponential here, and what you get is ln of a fourth is equal to k times 10, or k equals ln of a fourth over 10. Okay, but that's not what the problem asked us for. The problem asks us, what is the half-life? And what is the half-life? It's the time t for which half of it is gone. Or in other words, if half is gone, then that means there's half left. So what we really want to figure out is, when are we going to have half of our initial amount? So we plug that in, and this time we don't know, sorry, there should be an a out front. This time we don't know what the value of t is. Okay, but we now do know what k is, right? So we spent the first time figuring out what k is. So that's a e to the ln of a fourth over 10 times t. T is the mystery time that we want to solve for. Again, we have another variable in the equation, a, but we don't need to worry about it because it cancels. So what this is saying is it doesn't matter what the initial amount is. If you know how long it takes to get to a quarter of the initial amount, then you'll always be able to figure out, it's always going to take the same amount of time to figure out the half-life. So that cancels, you get e to the ln of a fourth over 10 times t. Okay, now we have to be very delicate here because a lot of you guys, for whatever reason, are making basic algebra mistakes. So when we solve this, we want to get rid of this e, so we're going to take the ln of both sides again. And don't screw up what's going on here. The ln cancels with the e, but that's the only thing that cancels. It just means everything in this exponent comes out. So we have ln of a fourth divided by 10 times t is equal to ln of a half. So then you can solve for the time. It's just 10 times ln of a half divided by ln of a fourth. please do not make the mistake of just saying, oh, the ln's cancel. That is certainly not true. Okay, but what you can notice is, hey, wait a minute. A fourth is really just 1 over 2 squared, or you can think of that as 2 to the negative 2 power, right? The negative means 1 over, and it's 1 over 2 to the 2. Whereas 1/2 is even easier. That's just 2 to the negative 1 power. Okay, so this is really just 10 times ln of 2 to the negative 1 over ln of 2 to the negative 2. All right, but wait a minute. What property do logarithms obey? The exponents pull out in front, right? So ln of 2 to the negative 1 is that negative 1 comes right out front. Negative 1 times ln of 2. ln of 2 to the negative 2 equals that negative 2 comes out front. Negative 2 times ln of 2. So we can rewrite this instead as 10 times negative 1 times ln of 2. And the bottom is negative 2 times ln of 2. And now the ln of 2's cancel because they're actually the same thing. And this negative cancels with this negative sign up here, and you just get 10 divided by 2. Multiplying by 1 doesn't change anything, and that just gives you 5 days. So that's the answer. There's a way you could have gotten at this answer conceptually instead, if you prefer. You could have said, well, I know something about how these things work exponentially. And it means that the ratio, the quotient of how it changes, rather to say that if a certain fixed amount of time passes, the question of how much decays, you can't say, oh, well, 3 of it decays here, so 3 of it will also decay here. That's not the way exponentials work. If you wait the same time period, what matters is not the amount that decayed, but the percentage that decayed. So I warn my students here, maybe you shouldn't approach this in this kind of cheap way, this kind of thinking about it qualitatively instead of actually following through the formulas. The formula won't steer you wrong. If you just follow this approach, then it doesn't matter what the numbers are. But if you want to see how it's done, you could say, well, look, we get to a fourth after 10 days. Which means we would have gotten to a half in half that time, 5 days. Because we shrink to a half of our original amount in 5 days, then we shrink to a half of a half in 10 days. So it would have been there in half the time. So that's the way that it conceptually should work. You could have just figured it out, and some of you did, but a lot of you tried to figure it out this way, and you got confused about how this sort of thing actually works. So you ended up with weird answers that were not accurate. So I would just stick with this formula. Also, by the way, the only reason this kind of trick works is because, well, a fourth is exactly half of a half. If it didn't work out so cleanly, if, for example, they told you what it was after a third, or how long it took to get to a third of its original size, and they asked you for the half-life, then there's no easy game you could have played. So make sure you really understand the actual algebraic way of doing it. Alright, the next question was, this time we're growing, and it says we grow to 4 times our original amount so we're using the exact same formula, and it really doesn't matter whether we grow or not, or whether we're growing or decreasing. It's the same formula. This time it takes 8 hours. Or, sorry, it takes 6 hours. Okay, so we play the same game exactly as before. The a's cancel magically. 4 equals e to the k times 6. ln of both sides gives us ln of 4 equals k times 6. Ln just cancels with the e. And so k is equal to ln of 4 divided by 6. But again, they didn't just ask us for what k is. They asked us, when does it get to 8 times its original size? Okay, well, so the question is, when does it get to 8a? So 8a equals e to the, now we know what k is, it's ln of 4 over 6 times t, and t is what we're trying to solve for. The a's cancel again, this sort of thing does not matter. So we end up with 8 equal to e to this. We can take the ln of both sides again. I'll just skip right ahead and do ln of 8 equals, and again, don't screw up with this. The ln cancels with the e, but that's it. The entire exponent as is comes down. Ln of 4 over 6 times t. And if we solve, this is 6 times ln of 8 divided by ln of 4 is equal to t. Please do not just cancel the ln's. That does not work. What you have to write is 8 is 2 cubed, and 4 is 2 squared. So ln of 8 is ln of 2 cubed, and that cubed comes out in front as a factor of 3 ln of 2. Similarly, ln of 4, ln of 2 squared, the 2 comes out, and that's 2 ln of 2. So we can rewrite this as 6 times 3 ln of 2 over 2 ln of 2, and now the ln of 2's are the exact same thing, and they can cancel. And you have 6 times 3 over 2. 18 over 2 is 9. I think the unit we were dealing with was hours. 9 hours. You could have done this conceptually. You could have said, look, at some point I'm going to double. Then I'm going to double again, and when I've done that, I've done a total of quadruple. And they told me how long it takes me to quadruple. They said it takes 6 hours. So since this takes the same amount of each time, it must have taken me 3 hours the first time to double, and then another 3 hours to double again to get to 4. So I want to double one more time, 2 times 2 times 2, to get to 8. 8 times my original amount. That'll take me another 3 hours. So it would have been a total of 9 hours. But again, instead of trying to handle it conceptually, it's probably a better approach. It's more reliable to do it the more algebraic way.